Welcome to this panel. My name is Thierry Hillis. I'm the editor of Global University Venturing, and I'm just here to briefly introduce our next speaker, who is Jim Wilkinson, the Chief Financial Officer at Oxford Sciences Innovation, who is going to tell us why the future is in our universities. Over to you, Jim.
Thank you very much, Thierry, and thank you for having me. In the next 20 minutes, I'm going to illustrate how I believe our universities can play a pivotal role in solving some of the world's toughest problems. But I'm also going to talk about the challenges surrounding how we take the amazing science created by our universities and turn it into technology innovations that can impact the real world. Breakthrough science can only impact the real world if there's an effective route to commercialization. As an early example of how this should work, I want to take you back to the 1920s and one of the most important scientific discoveries for mankind. This is the story of penicillin. Everyone associates penicillin and the dawn of the antibiotic age with Alexander Fleming. However, Fleming discovered penicillin completely by accident. He then found the antibiotic impossible to isolate in a pure state and gave up on the project. In 1939, Ernest Chain and Howard Florey began experiments with Fleming's mold at Oxford and managed to turn it into a useful product. It fundamentally changed medicine forever. 2 years later, pharmaceutical companies in the United States banded together to devise a high-capacity industrial process that enabled that product to be distributed worldwide. And penicillin has gone on to save something close to 200 million lives. This example clearly indicates how the application of fundamental science to the real world can be one of the main drivers for human progress. Other great examples where science and technology have transformed standards of living in the 20th century include plastics, the lithium-ion battery, the blood glucose test, integrated circuits, and gene therapy. And all can be traced back to academic breakthroughs in the natural sciences, engineering, and medicine. A major player in the 20th century was the Corporate Innovation Lab. And it's important to recognise that a large part of the 20th century, the Corporate Lab was responsible for researching and commercialising many of the most important technologies of the last century. And examples include GM, who conducted early automobile research that led to the cars we use today, IBM, who laid the groundwork for the electric computer, Bell Labs, now owned by Nokia. In the late 1960s, Bell Labs employed 15,000 people, including 1,200 PhDs. Between them, they made too many important inventions to list, from the transistor, a crucial building block of modern technology, to the photovoltaic cell, the first digitally scrambled voice audio, and the first complex number calculator. There were 9 Nobel Prizes awarded for work done in the lab, and 5 employees won the Turing Awards. But for the last 40 years, we've seen corporate innovation dwindle. Research as a percentage of corporate R&D has fallen from 30% of total spend in 1985 to 20% in 2015. So less corporate dollars on finding the science, more corporate dollars on development. And this is translating into a reduction in innovation from corporates. R&D magazines, which award the R&D 100 to the 100 innovations it judges most innovative, gave 47% of its awards to Fortune 500 companies in 1975. But by 2006, this number has dropped to only 6%. The majority of these awards are now won by federal labs, university teams, and academic spin-outs. Fortunately, global investment in technology startups is booming. The digitization of the global economy has attracted enormous investment. Social media and e-commerce have made big changes in the way we live our lives. However, my argument would be that we have not seen focused investment or technological advancements in the arenas that matter most. Technology can do anything, other than the things we really need it to. Some people call this the technology paradox. And if there's one thing the last year has taught us, it's that innovation needs to do more to address our shared societal challenges and opportunities, like climate change, global health, and inequality. Governments are now placing science and technology innovation at the core of their strategies to tackle major issues. We need investment in the science, innovations, and technologies that matter the most. It is therefore no surprise to see governments now specifically placing science and technology innovation at the centre of their strategic thinking. As an example, the UK government set out 4 grand challenges as part of their 2017 industrial strategy, focused on AI and data revolution, innovation for healthy aging, low carbon emissions and clean growth, and future mobility. All of these need solutions driven by science, technology, and innovation. And that is where our universities have a massive role to play. Breakthrough research has moved from commercial labs to universities. With corporate research declining and governments now stepping in to promote scientific innovation and investment, it is increasingly going to be the role of universities to generate the breadth and depth of science required to meet the challenges facing mankind. Fortunately, university labs are more productive, creative, and innovative than ever before. Breakthroughs in quantum computing, nuclear fusion, and advanced medical diagnostics are just some examples of the amazing progress being made. If we just look at Oxford and the science that underpins our 5-year-old portfolio, you'll get a sense from this chart just how rich and varied the scientific landscape is. This sounds encouraging, but there are two fundamental issues that need to be addressed if we're going to see the cadence increase in turning science into real-world applications. The first is identifying and patenting novel technology. But UK universities do not successfully translate and commercialise research as optimally as they could. Between 2011 and 2016, the UK published 80 papers per patent compared to just 7 papers in Germany and 11 in the US. So despite the incredibly high research output from UK universities, it is not being translated into commercial impact. Research by the Wellcome Trust has found that UK academics are about half as likely to patent as their counterparts in a top US cluster. This could explain why 8 of the top 10 universities for commercial output and patenting in the world are based in the US. In fact, only 6 UK universities feature in the top 100 versus 46 for the US. So why is that? Are we creating the right incentives and opportunities? In the UK, the principal metric for academic success is paper citations. This pressure to publish can disincentivise UK researchers from filing patents. We just haven't been good enough at creating the right opportunities and incentives. The Wellcome Trust found that UK academics were much more likely to pursue publishing papers over other routes such as commercialisation, because they felt that this was the best way to drive grants or further their career. And research by the UK's Medicines Discovery Catapult concluded that researchers in the life sciences space lacked access to the skills and funding needed for early stage translation and concept testing. There's work to be done to help bring research out of the lab and into the real world, and this is what OSI was founded to do. This is OSI's mission: to enable scientists and entrepreneurs to build companies that solve the world's toughest problems. OSI turns great ideas into companies. We need to be capable of attracting investment and the talent needed to succeed. We need to bridge the gap between fundamental science and real-world application. And we need to act as the catalyst for the commercialisation of academic research. In partnership with the University of Oxford, OSI invests in fundamental technologies companies built on science. We match Oxford scientists with experienced entrepreneurs and patient capital investment. The science is focused on finding ideas that will tackle the world's biggest problems. The entrepreneurs, great companies also need talented management and strong commercial expertise. And scientists are unlikely to also play the role of CEO, especially in the long term. For investment, we need patient capital. This is long-term investment, giving the companies the time they need to invest to succeed. We do this by building trust with the university, its academics and researchers, and we are building a positive reputation across the full Oxford ecosystem, as well as nationally and internationally. The OSI investment model. Our investment model is a recipe for success. OSI excel in the identification, creation, and manufacture of companies, but we need external commercial expertise to scale up and grow these companies. We therefore focus our efforts on progressing and supporting the portfolio companies through the first 3 stages of investment: pre-seed, seed, Series A. We then identify and bring in strategic partners and validating capital in order to provide companies with domain-specific expertise capable of scaling up the company, ready for growth and exit. And we reinvest back into the Oxford ecosystem to create more companies capable of tackling more of the world's toughest problems. The portfolio is attracting capital from strategic partners, with most investing in Oxford for the first time. These are a sample of the people that have come in and invested since we started in 2015. Apart from Parkwalk, I don't think any of these had invested in Oxford spinouts before. This is a small grouping of what we need going forward. We still are out there trying to attract the right partners for the right companies. These are examples of strategic partnerships. So each of our corporates, we're also out there trying to improve their access to commercial partnerships. So through the network that OSI brings, we try to make sure that they get introduced to companies that can accelerate the growth of moving from scientific discovery into commercialization. We also try to help them when it comes to get funding. So at Series A, I've said we're covering so many different areas across our portfolio, all the science from Oxford, that we're trying to bring in companies that can actually help us take them from Series A through to exit. The sale of Base Genomics to Exact Sciences for $410 million shows OSI model working at its best. We actually incubated this company for almost 2 years, and then started it in late 2018, and actually it's exited. It launched as a company in June 2020 and actually exited in October. It developed the world's leading DNA methylation technology. What has happened with Exact is they will invest in the base team in Oxford, which we expect to be in tens of millions of dollars, and use this as their European base to accelerate the development of early cancer detection technology, which will ultimately help patients. OSI's return from this investment will be cash that we reinvest back into the Oxford ecosystem, creating more companies capable of tackling more of the world's toughest problems. OSI's experienced investors are supported by a central team and advisors that are leaders in their field, along with external partners. However, we're a small team in order that we can provoke a bespoke service, and every spin out is treated separately and is different from each other. The niche knowledge, skills and experience required for individual success, the ability to bring in validating capital and strategic domain partners are vital. And that is why we bring in validating capital at Series A. This is the slide we call the explosion slide, and you can see that our model is starting to work. Between the first spin out back in 1959 was Oxford Instruments. You can see the technology, the OUI, the Technology Transfer Office in Oxford, was set up around about 1998, and OSI was set up in about 2015. So you can see between 1997, 98 and 2015, there were on average 4 or 5 companies a year spun out of Oxford technology. Given that OSI provided the capital, you can see what has happened from 2015 onwards. And I think it's true to say that across the university system in the UK and Europe and in many other places of the world, it's the lack of capital that is holding the move back from research into commercialization. It's also worth noting that prior to the establishment of OSI, in the period between 1998 and 2015, about £500 million was invested in these companies across that entire period. Between 2015 and 2020, the same amount of money again has been invested in just 5 years, i.e. £500 million. Our expectation is that in the next 5 years, that number will be more like 4 billion as these companies get bigger, require more capital. Hence the need also to bring in validating capital and other capital providers. So I'm leaving you with this slide, is we enable scientists and entrepreneurs to build the companies that solve the world's toughest problems. Thank you for listening very much, and I'll hand back to Thierry now.
Thank you very much, Jim. Very fascinating presentation. I don't think we have time for questions, but we do have a power break, and I would invite people to go and grab a fresh cup of coffee and come back, because we are staying in universities, and we're heading to University of California for their spotlight on their winner from the challenge on Friday was. Thank you very much, Jim, for joining us today. And do enjoy the rest of the conference.
Small business owners.
This is How to Grow a Small Business.
What makes companies succeed the most?
Very rewarding from my side, rewarding from theirs. We've achieved a lot in a very short period of time. 5 lots of 2-hour workshops have generally achieved far more than any of us could have hoped.
Thanks to Star Venture program, we are really growing quickly and scaling up. Nowadays, we build the security robot in 3 weeks. Thanks to Star Venture program and to this specialist, we are working to build it just in 72 hours at the beginning of 2021.
We had a problem as we have entered the artificial intelligence sector. We did not have the right resources and expertise to complete our product. Thankfully, through the help of SVP, we managed to access excellent talent in a few cities in the EU, and we are currently developing our R&D in AI.
It was and still is a wonderful journey, and I hope many more companies work with the Star Venture program, and I thank the team for everything they've done with us so far.